Okay, this is lesson 3.4, conditional statements. Okay, we are on lesson 3.4, the conditional and related statements. The objectives are we're going to determine the converse, inverse, and contrapositive of a conditional statement, translate conditional statements into alternative forms, understand the structure of biconditional statements, and summarize the truth tables of compound statements. Okay, first, conditional statement. If P then Q, that's our original statement. The converse is if Q then P. Inverse, you're taking P and Q and you're flipping them. Or the inverse, you're taking the P and making it a not P, Q and making it a not Q. Contrapositive, you're taking the inverse and you're flipping it. So the converse is the if Q then P is the consequent is first and the antecedent is second, whereas in the conditional statement the antecedent is first and then the consequent is second. All right, so let's take a look. Determine each of the following given the conditional statement. If I am running, then I am moving. So P, we're going to write that is I am running. I am running. Q, I am moving. Moving. Okay, so when we're saying, so this is what I like to do is go ahead and write it down. So if I am running, I am running, comma, then I am moving. Okay, so this is your original if P then Q statement. Okay, so now you want from here, they want us to write the converse. So the converse to that is if Q then P. So since Q is I am moving, that's what you're going to, so this, since Q is I am moving and P is I am running, then you're going to write if I am moving, then I am running. If I am moving, because that's Q, then I am running. Okay, Q is I am moving, so this will be if I am moving. P is I am running, so this will be if I am moving, then I am running. Okay, that's the converse. Next, we want the inverse. Okay, so the inverse is not P, if not P, then not Q. So that's pretty close to the original statement. The only difference is you're going to put if I am not running, then I am not moving. Okay, since P is I am running, then the inverse would be if I am not running. If I am not running, comma, then I am not moving. Okay, so that's the inverse. Okay, next, the contrapositive, that's where we're taking the inverse and we're flipping it. So the contrapositive is going to be if not Q, then not P. Okay, so all we're doing here is we're going to write this, if I'm not moving, then I'm not running. If I am not moving, comma, then I am not running. Okay, so that's what we're doing there. Alrighty. A conditional statement and its contrapositives are equivalent. Okay, so what we mean there is when we look at the truth tables, the conditional statement and its contrapositive are equivalent. So let's see how we would do that. We have P, Q, and if P, then Q. And we've got true, 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 false, false, true, false, false. The only one that's false is if true, then false, because it's like a lie. So let me switch screens. Okay, so we have P, Q, if P, then Q. So we have true, 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 false, false, true, false, false. The only one that's false is if true, then false. If your friend says he's going to go to the party and he goes, he told you the truth. He went to the party. So that's a truth. If your friend says he's going to the party but he doesn't go, that's a lie. So that's false. If he says, well, I can't make it to the party, but then he shows up, he didn't lie. He just, it's unexpected, so that's okay. That's true. He didn't lie. And he says, well, I can't go to the party, and he doesn't go. He didn't lie, so that's still a true statement. Okay, so the only one that's a false statement is if he says he's going to go to the party and he doesn't. That's a false statement. Okay, everything else is true. So contrapositive, P, Q, if not P, or if not Q, then not P. Okay, we have true, 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 false, false, true, false, false. All right, so you have to, okay, so if Q is true, then not Q is false. If P is true, then not P is false. So we're saying if false, then false, that's true. Because the only one that's false is if true, then false. If P is true, then not P is false. If Q is false, then not Q is true. So we're saying if true, then false is false, because that's the only one that's false. If P is false, then not P is true. If Q is true, then not Q is false. If false, then true is true, because the only one that's false is if true, then false. And so if P and Q are both false, then not Q and not P are both true. And if true, then true is true. So you can see here, if true, false, true, true, and true, false, true, true, they're equivalent. So we can say if P, then Q is equivalent to if not Q, then not P. Okay, so this triple looking equal sign means equivalent. So they're equivalent truth tables. Okay. All right. So, and the same thing, what happened would hold true for converse and inverse. Converse is where P and Q is flipped. Inverse where it's not P, if not P, then not Q. Okay. Alternative forms of if P then Q. So here we have if P then Q with an arrow. If P then Q. P, it can also be written as if P is sufficient for Q. That's another way to write it. If P, comma, Q. So in other words, if we're saying if it is a cat, then it will climb up a tree. Well, this part here, if P, comma, Q, you could say if it is a cat, comma, it climbs up a tree. So the then is left out. P implies Q, so if it is a cat, that implies it will climb trees. All cats climb trees. All P are Q. Okay? So that's how that would work. Okay, so rewrite the statement in the form if P then Q. So what I like to do is I like to define what P and Q are. So in this case, equilateral triangle, triangle is the P, and the Q is all angles are equal. All angles are equal. Okay, so let's look at the board. So we want to rewrite this. All equilateral triangles contain all equal angles. So you could write this as if it is a equilateral triangle, comma, then it has all equal sides. Okay, if it is an equilateral triangle, then it has all equal sides. So we took this this common statement, an equilateral triangle contains all equal sides, and we converted it to a conditional statement. If it is an equilateral triangle, then it has all equal sides. Okay, so that's how we're taking the if then to a application form. Okay, so all dogs have fleas. So P would be dog, Q would be has fleas. Okay, so we want to make all dogs have fleas into a conditional statement. So we want to go if P then Q. Okay, so we would say if it is a dog, comma, then it has fleas. And that's where it gets back to all P are Q. If P then Q. Okay, so that's how that works. All right. All right. I will go to the beach if the sun is shining. If the sun is shining, then I will go to the beach. All right. Okay. So biconditional statements. That's where if P, if and only if Q, or IFF, it's called a biconditional statement. It's symbolized with this double arrow looking if P then Q. Is interpreted as a conjunction of if P then Q and if Q then P. Let's see how that looks on a truth table. All right, and we'll start with that. So P, if P then Q is the same, is equivalent to if P then if Q then P. Let's write this down, P and Q. So this will be if P then Q and if Q then P. Okay, so we got true, 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 false, false, true, false, false. All right. So we're saying if P then Q. If true then true is true. If Q is true and P is true, then if true then true is true. So true and true is true. Okay. Okay, so if true, then false. So P is true, Q is false. If true, then false is false. And here we're saying Q is false, P is true. If false, then true is true, because the only one that's false is if true, then false. So we're saying here false and true is false. Okay. All right. So P is false. Q is true. If false, then true, that's true, because the only one that's false is if true, then false. Okay. So now here Q is true. P is false. If true, then false is false, because the only one that's false is if true, then false. So now true and false also. If false, then false is true. So if and true is true. So true, false, true, true is the biconditional. If you have two truths or two falses, those are true. If you have a true and a false, that's false. We knew that before from a conditional statement. But if it's going back the other way, if true, then if false, then true, that's true. But if true, then false, that's what this is. If false, then true, that's true. But then if true, then false is false. So if true, then false, this is going back the other way. And so that makes it a false. So if there's a true false or false true for biconditional statement, it's false. Okay. Whereas with PQ, with just a conditional statement, no double arrow, right? It's not biconditional. True, true is true. True, false, that's the only one that's false. False, true, that's true. False, false, that's true. Okay, so that's a comparison between a conditional statement and a biconditional statement. Okay. Okay, and that's if and only if. And so that's what we have here for our biconditional statement. True, false, false, true. Okay, so, all right. Determine whether the biconditional statement is true or false. Okay, so let me get my board erased here. And the P, that's going to be 6 plus 8 equals 14. Q is 11 plus 5 equals 16. So we're saying if P, then Q. Okay, so this is A. Okay, so P, we said 6 plus 8 is 14. That is true. 6 plus 8 is 14, so that's a true statement. 11 plus 5 equals 16. That's a true statement. So we're saying here, if true, then true. If true, then true, true. That's going to be true, right? Because we're saying if P, then Q. If 6 plus 8 is 14 and 11 plus 5 is 16, it's true. If 6 plus 8 equals 14, that's true. And 11 plus 5 equals 16, that's true. Then going back the other way, that's true as well. Okay. So the next one, P and Q, 6 equals 5. If and only if 12 does not equal 12. Okay. So here's our board again. So this is P, biconditional statement Q. So remember now, both of these either have to be true or both have to be false in order for the biconditional statement to be true. If there's one true and one false anywhere, then it's a false statement. Well, 6 equals 5, that's a false statement. 6 does not equal 5. 12 does not equal 12, that's a false statement. So we're saying if P is false and Q, if P is false, then Q is false. And if Q is false, then P is false. So false, false, false and false, and false and false going back the other way. That's a true statement because they're both false. In order for them to be a false statement, it's if one is true and the other one's false. So that's a true statement. Okay, so Mars is a moon if and only if Jupiter is a planet. Okay, so P, we're saying Mars is a moon. Q, we're saying Jupiter is a planet. Okay, so here's how we would write that out on a truth table. We're saying Mars is a moon, Jupiter is a planet. If P, then Q. Okay, so Mars, is Mars a moon? No, it's false. Jupiter, is that a planet? Yeah, that's true. So we're saying if false, then true, that's okay, that's true. But if true, then false, going back the other way, that's why you have the two arrows, because you're looking at it one way and going back the other way. So if false, then true, that's okay, that's true. But going back, if true, then false, no, that's a false statement. So that gives us a false. Okay? All right. Okay. All right. And so this is a summary, negation, conjunction, that's and, right? And. The V-looking symbol is a disjunction. Is false only when both P and Q are false. So you only need one or the other to be true. That should be, okay, so that's an or statement there. If P then Q, if P is true and Q is false, the only false is if P then Q. If P is true and Q is false. Biconditional statement with the two arrows is true only when both P and Q are the same. That's a good way to write that. They're the same, both true or both false. And that concludes lesson 3.4. Have a good day.